right side, and at the bottom, at the middle, it is flowing towards the direction of here, opposite to the main field flux. Similarly, if you observe here, the direction of you can see the camera, direction of current is outwards. So how should I point my thumb? I'm pointing my thumb outwards. As I'm pointing my thumb outwards, direction of magnetic field. How is the direction of magnetic field? How these curled fingers are in the direction? You can use the chat box and you can message so that I can confirm that we both are not sleeping. What is the direction of this magnetic closed fingers, curled fingers? Fast. Anti-clockwise or clockwise? Others? What? Anti-clockwise direction. Yeah. So the answer is anti-clockwise direction. Okay, that's good. So there are some talented guys out there who will wait for my answer. Yeah. So again, I'll try to segregate. Don't worry. Okay. Yeah, you can stop. So as it is flowing in the anti-clockwise direction, I can say that. So here this is the direction of flux. And here this is the direction of this. So you can get a conclusion that that's okay, that's enough. Okay, you can stop posting your answers. So you can get a conclusion that due to the effect of these three conductors at the top and these three conductors at the bottom, the flux which is generated, that is flowing opposite to the mean field flux. That is flowing opposite to the mean field flux. Now which portion of the conductor main field flux is affected here? This is the portion, actual portion. To this portion, the armature flux is flowing opposite. Now if I assume that 100 is the main field flux and this armature flux, these blue symbols, yeah, let me try to add one more shape. Yeah. So this is the main field flux. If this is 100 and this the opposite flux is 10 plus 10. If it is 20, as both are in the opposite direction, there is a reduction in the main field flux. 100 minus 10, 100 minus 20, that is equal to 80. So as there is a reduction in the flux, we can call it as demagnetization is taking place. Just I'm confirming, I'm re-verifying. We can cross-verify in so many ways. So, and which portion of the conductors are leading to the demagnetization? These top and bottom portion of the conductors are leading to the demagnetization effect. That's the reason I'm making a conclusion that, and this portion of the conductors are cross-magnetizing conductors or turns. Turn relation between turn and conductor is nothing but one turn has two conductors. That's it. One turn has equal to two conductors. So one conductor equal to turn by two. That's it. And this portion of the conductors are demagnetization turns. Okay. So this is what we discussed. So we finally divided the cross magnetization and demagnetization turns from the armature. Okay. Just to okay. So just to test others. Okay. I'm asking you everyone to raise your hands now. So within half a minute, I'll going to make a count. Two not 3, 14, 31, 34, 55, 60, 63, 73, 85, 96, B1. The video is recording. I can note down these numbers, and if you're still not there, I can give you absent. Yeah. Okay. Next time onwards, I am not going to wait for more than 30 seconds. Okay. 55, 63, 73, 96. So consider that you are absent. Okay, yeah. So I have an option to just to remove the participants if they are not active. I'm sorry. Okay, just to make you feel interest, I need to do this. So thank you all. Thank you others for listening to me patiently. Just you can lower your hands. Thank you. Yeah, I'm asking everyone to lower your hands so that we'll continue the class. Okay, I normally what I expect that if something wrong is with my teaching, then you can sleep. Okay, or else if you have any queries, you can ask me. When I'm teaching to the up to the extent, okay, then you need to listen. Normally, this is what I normally felt. Okay, yeah. So others also lower your hands. So if you raise your hands, then then I need to think that again you have any queries. Anyone still okay? Still two people. 210. Lower your hand. 210 fast. Okay, yeah. So now we'll get into the actual topic. So I thought that explain this portion importantly so that we can cover all the contents. Now here let's try to see this. We'll try to divide get a derivation here. So let the total number of conductors are Z. So if I'm assuming that there are total number of conductors, if the conductors are 100, then the turns will be half of that. A single turn can be half of the a single turn will have two conductors. So that if the total number of conductors are 100, then the number of turns will be 100 by 2. That is equal to 50. So turns equal to Z by 2. And I'm assuming that there are p number of poles. Just I'm making a derivation. So which portion of ampere turns per pole? 80 ampere turns. mmf equal to ni that is equal to amperes. N equal to number of turns and A equal to currents. So in order to find out the mmf ampere turns, okay, we need to find what is how much portion is demagnetization. Conductors are generating the ampere turns and cross magnetization is generating the ampere turns. So in order to find out that, just I'm doing that simple calculation. It's easy. So here the total number of turns are Z by 2. So we already know that in case of DC generator, we have that for lap winding A equal to P and for wave winding A equal to 2, and we have to divide according to the cases. So by considering the number of parallel paths, so here this is Z by 2, and if I multiply ampere turn, this is turns now. This Z, if you have running notes, you can keep on, you can continuously note down. So this is Z by 2. And if I want to convert this into ampere turns, what I need to do here, just I need to multiply IA. I need to divide by IA, and how many paths are there here? A paths are there. So Z into IA by A. Z into IA by 2 into A. Z into IA by 2 into A. So this is total ampere turns. So for wave winding, we have two paths, and for lap winding, there are P paths. So for generalizing, I'm making a conclusion that is A parallel paths are there. If 100 amperes of current is there and there are 4 paths are there, so 100 by 4 equal to 25. The same manner I'm writing here IA by A. 100 by 4 how it is converting, in the same manner I'm using IA by A. The same example I have explained even in the previous unit also. So total ampere turns per pole. This is the total ampere turns. Total ampere turns equal to Z into IA by 2 into A. So this is Z by 2. If I'm multiplying with the current in that branch, I need to multiply IA by A here. So total amperes per pole. How many poles are there? There are 2 poles are there. Suppose if n number of p number of poles are there, then I need to divide it by p here. So in order to find out the demagnetization ampere turns per pole, in order to find out the what is the demagnetization ampere turns per pole it is generating. So you can see this in the diagram. You can see in the diagram. So here, this amount of shift MN axis is making is theta. The amount of shift MN axis is making is theta. So that, so even the opposite side portion also making the demagnetization effect. So here theta plus theta equal to 2 theta. At the bottom also there is theta plus theta, 2 theta. So 2 theta plus 2 theta equal to 4 theta. So total in the armature, what is the demagnetization effect that is taking place here? That is 4 theta demagnetization effect is taking place. The total demagnetization, there is 4 theta effect is demagnetization effect is taking place. 4 theta demagnetization effect is. So I can say that there is an competitive exam question in the DC emission of an armature. What is the portion under which demagnetization effect is taking place? 2 theta, 4 theta, 360 minus 4 theta, and none of the above. The answer is 4 theta. The answer is 4 theta. So here theta plus theta. So here total equal to 4 theta. Now this is for 2 poles. If I want to consider the demagnetization effect per pole, then I need to divide it by 2 here. As there are 2 poles are there here, 4 theta by 2, that is equal to 2 theta. Now total electrical angle covered by each pole. We already made a conclusion that each pole covers an angle of 180 degrees. And we even discussed that there is a relation between electrical angle and mechanical angle. So electrical angle and mechanical angle. Now, so I just want to find out the relation of a demagnetization ampere turns per pole here. So if I assume that one pole, north pole, then demagnetization effect is 2 theta. And what is the total electrical angle it is covering here? 180. So if I want to find out this portion of effect here, so the area covered by the demagnetization by the total area covered by the pole. So what is the area covered here? It is 2 theta. And what is total area covered? That is equal to 180 degrees. So I can make a conclusion that class down now. Okay, can you hear me, guys? Can you confirm me? Can someone confirm?
Yes.
Yeah, okay, sorry, I got a call from the department. So 2 theta by 180 into this total ampere turns will give us the demagnetization ampere turns. That's it. If you might be, if you see any other this derivation from any other textbooks, that will be so much complicated. So it will be lengthy. It covers almost 1 page. So just to avoid all this confusion, just I'm making this simple. If you understand the theory concept in the better way, then it's just a 2 lines derivation. And so many times even asked for 10 marks question also. So here, what is the demagnetization ampere turns per pole here? The area covered by the demagnetization for each pole is 2 theta. And what is the total angle? Electrical angle is 180 degrees. 2 theta by 180 into total ampere turns. What is the total ampere turns? Z into IA by 2AB. That's it. I hope there are no queries here. And next one is cross magnetization ampere turns per pole. Now I'm finding per pole here. When I'm asking you to find the per pole here, I need to consider 2 theta. If it is total, then I have to consider 4 theta. Now, if I assume the north pole and this is the demagnetization ampere turns per pole effect, then that is 2 theta by 180. If I want to find out the rest of the portion here, let's assume that the total ampere turns per pole is equal to 100 and north pole is generating 50 and south pole is generating 50. Now here demagnetization, due to the demagnetization, it is it is leading to the effect of 10 ampere turns per pole, and for north pole we are generating 50. So in order to find out this unknown parameter, what is the value? How can I able to find out? Can someone tell me? Already I told you that I will not deduct any marks. If possible, I'll try to add marks if you involve in the session. For a north pole, if the total ampere turns per pole is 50 and the area and the ampere turns per pole covered by the demagnetization is 10, then what is the other value? Is everyone is from MPC or not?